So I'm Baldeep and this is my interview video. So the question asks us to find three things: when the planes intersect at a point, when they intersect at a line, and when there are no solutions. So first we should figure out when there are no solutions and when the planes intersect at a line, because that will help us solve for when the planes intersect at a point. The first thing you can observe by looking at these three planes are that none of them are parallel or distinct to each other, which basically means there's no value that you can multiply one entire equation by to make it to equal one of the other equations. So another way no solution could occur is when the matrix has a 0z equal to any other number, or also known as 0z equal that 0z can equal 0. So this equation we know is false because anything multiplied by 0 is 0, so there's no way that we could be equal to any other number. So what we're going to try to figure out first is how to get the matrix to have a 0z equal to 0, because we know that this statement is true, which we can use to figure out at what line the planes will intersect. So it's in the first matrix here. I put the three equations into this matrix. So what we're going to try to do is make the first two values of the both third row equal to 0, but also the first value in the first row equal to 0. So for the first step I saw in making the bottom two values 0 is I saw a 1 in the first x column in the first row, and I saw instantly that by multiplying that by 3 we can easily subtract row 1 from row 3 to make the x column in the third row to equal 0 right here. So now what I also needed was to make the x value in the first row to also be 0. So I knew that if I made this value 0, it would help later on making the y column in the third row also 0. So to do that, I did k row 1 minus row 2. This turned the x value in the first row to 0. So moving on, what I did to make the y column in row 3 0. So this equals 0. I multiplied the entire row 3 by 4k plus 5 right here, and then I added 34 times row 1 to that row. So then we are left with the z value in the third row of 8k squared minus 8k minus 48, which is equal to 4k squared plus 71k minus 249. So what we're trying to get is 0z equal to 0 to get the line solution. So now what we did was we took those two equations in the third row and we set them equal to each other, and then we factored the equations. So in the first set equation I factored out the 8 first, and then I found two values that multiply to -6 and add to -1, which were +2 and -3. So in conclusion, that gives us a k value of -2 and k equals 3. And by looking at this equation, for the fastest way to factor it, I put it in quadratic formula, and in the end result it gave us a value of k equaling 3 and a value of k equaling -83 over 4. So from here we see that when k is equal to 3 on both sides of the equation becomes 0. The equation will become 0. So we can take in fact that when therefore k equals 3 will lead to 0z equaling 0, which basically means it's a line solution. Now we also know that when 0z can't equal 0, we get no solutions. So if we look back at our k values, for the left side we know that when k is equal to -2, the left side becomes 0, but the right side doesn't become 0 because the quadratic formula solution did not give us a value of k equals -2. That means when k is -2, we get 0 for the left side, and we get -375 for the right side, which means we have a point solution, since left side is 0 and right side is not. So when k is equal to -2, we get 0z equaling -375, which means there's no solution. By knowing this information, we can easily understand to get point solution k can be any other value in the real number system except for -2, since that gives us no solution, and 3, since that gives us a line. So the value of k can be any real number in the real number system, such that k cannot equal -2 and 3, because these values, the -2 value will give you a no solution, and the 3 value will give you a line solution, and any other value will give you a point solution. That is my video. Thank you.